All right, well, welcome to the second part of our discussion and our foray into arrays, chapters 11 and 12 for C++, CIS251. Remember in video 1, that's sort of a general discussion of the topics involved and the concepts for arrays. And I used a video I'd already created from C# because it's very similar, and I covered quite a lot of stuff in it. The only thing that you really got to be concerned with at this point was, that was done for GUI, which this isn't. C++ just uses the console app interface. But the main thing is that there's a little bit of difference in the syntax. And if you remember, if you go back and look, you'll see that for a two-dimensional array, instead of having two sets of brackets, opening and closing for the rows and opening and closing for the columns, you just had two brackets, opening and closing, and a comma in between, which you could size or not. C++ is somewhat different, but we'll get into that in a minute. All right, this is the first part of the little example program that I showed you, and as you can see here, I have a couple of function prototypes. One of them basically just iterates through a single-dimensional array and displays that. And the second one iterates through a two-dimensional array and displays that. All right. The other thing to remember about, or sort of refresh your memory about, is an array name is automatically a hexadecimal address of memory. It can be nothing else because it's not feasible to pass something that's huge, maybe enormous, by value to a function because it's so much overhead. So since it's, the name of any variable is the beginning address of memory, the compiler designers decided, well, we'll just make by default the name of an array the beginning hexadecimal address of memory. So it's automatically a pointer to the array. All right. For a single dimensional array, that's fine because you can call it whatever you want. That's what this is going to be. It's going to be the starting address of memory. Now, for a two-dimensional array, which is rows and columns, what I've done here is I didn't put a size in there because this is actually the starting address of memory for a one-dimensional array. And I don't want to get too technical here, but a two-dimensional array, let's just say of, well, in this case, integers, is actually a single-dimensional array of pointers to a single-dimensional array of integers. So the first one, you can kind of get away without passing a number in. Now, you can pass it in if you want. But because it is the starting address of memory, it can still get to this. But you do have to include the number of columns in there. So that's why I don't have a number here. I could just as easily have put the number in. All right, so, and then, of course, I've got my function declarations down here. All they really do is just loop through everything. So we'll look at those in just a moment and get back to the top here. All right, so here's the beginning of main. I have three one string variable and two integer arrays, or arrays of type int. All this is just MySpace string exclamation point. That's all it is. So it's a string with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 characters in it. Now here's how you declare a single dimensional array. Again, you can put the number of elements in there if you want to, or actually the highest index, I think is what it is. Let's see. No, it's the number of elements. So I've got 1, 2, 3, 4 elements here. I could just put 4. Or you can automatically leave it blank. It will size it if you're declaring something in there. Even if you have to declare zeros, it will still do it based on this, what they call the initialization list. And notice that since this is an integer, and regardless if it was or not, you start with a curly brace opening and a curly brace closing element. Then each one of these elements is separated or delineated by a comma. So I've got, at 0th element, I've got 1 and then 4 and so forth. So you'll see that when we actually look at it in the debugger. Now here's the syntax for a two-dimensional array of type int in this case. And what I've done here is try to graphically show you the rows and the columns, and there's a reason for that, because this initialization list looks a little intimidating if you don't really understand which is which. Okay, so the columns are vertical, right? And how many columns are there? Well, there are 3 columns from 0th index to 2. And the rows are horizontal, and there are 4 rows, right? That's 0, 1, 2, 3. So 0 through 4, that's 4 rows with the highest index of 3, because it's always one less than the number of elements. And this is, in this case, I'm explicitly, telling it how many of each. Now, notice here that I've got double brackets on the beginning and the end. For a two-dimensional array, and this is what we're doing here is called row major order. All right, we have 4 rows. So you have a set of brackets for the first row, a set of brackets for the second row, a set of brackets for the third row, which would be here, or index 2, and a set of brackets for the fourth row. And notice those sets of brackets are set off or delineated by commas. And then with each set of innermost nested brackets, I have my columns. So this is row 0, and this is column 0, column 1, column 2. See the numbers? 3, 6, 5. That's how you can kind of look at this and determine, if you understand it or not. So now this second set of brackets would be for row index 1 or row 2, however you want to look at it. And how many columns we have? 1, 2, 3. So for every row, we got to have 3 columns. That's because I specified it that size. And here again are your data items, 8, 9, and 6. And here's my third row, or row index 2. I have 2, 4, and 9. As you can see, 2, 4, and 9, and then 1, 0, and 6. So that's how you do it. Now, there are other ways. I mean, the book goes into a little bit more detail about if you want to zero out everything. You don't have to put zeros. You can just put one set of zeros in there or empty strings, and it'll just populate the whole thing that way. So those are nuances that probably are better left to your reading ability and practicing through the book. Okay, so we've got that sort of covered. Let me scroll up here. Now, here is a loop, and as you saw in the other video, the best way to traverse an array is a set of loops, or a single loop or a double loop if it's a two-dimensional array. If it were a three-dimensional array, you'd have 3 nested loops, okay? And again, this is basically set up as a row. So for every array item at X, I'm going to output it with a cout statement, all right? Now, I'm going to go ahead and run this. Hopefully it won't throw an error in. That'd be embarrassing, wouldn't it? Happened before. All right, and it's broken here. So what I want to do now is I want to go ahead and put a couple of watches in here for X, and then I want to do one for single array X, right? Add that. Okay, so I'm going to step through this. Notice right now that this is, it can't get to it yet because this is inside of a structure. All right, and so I'm basically outputting a number and then putting a space. And these are integers, and of course I'm using X as this is what drives my loop, X. It can be Y or count or whatever. So I'm going from 0 to 3 because there's 4 elements in this array. The first index is always 0, and the last index, or the highest index, is always 1 less than the number of elements. So again, it's got to be 3 or less, and that's why I'm using X less than 4. All right, and then I'm incrementing at the counter here with a post-unary operator. Post-increment unary operator, excuse me. All right, so let's see what we have here. F10 to step through. And so there's 1 is stored at the index of 0, right, because you can use the variable to map your indexes. And at index 1, I have 4. And index 2, I have 7. Index 3, I have 3. Now, let's go back up here and look. Is that right? 1, 4, 7, and 3. So there you go. All right, let me blow out of this. This should terminate the loop. And now let me pop this up and see what we got. Well, there's 1, 4, 7, and 3. Pretty straightforward so far. Okay, now I'm going to loop through my 2D array. And, you have this program, so you can always print it out or pull it up and follow through with me if you'd like. And let's see, we have row as our outermost or row variable control loop, and column is our innermost or column variable control. So there they are. Probably just get rid of these. And then I'm going to go ahead. Notice it's row major order, so I've got row and column, right? And add that. Okay. Now, if you had the logic class, you remember that for an array or for anything like this, you hit this outermost loop, which is for the rows. For every row, you've got so many columns you've got to look at. So for every row, and it starts off at 0, we've got to look at column 0, 1, and 2 and print out what's there. And that's how this works. Think of it like Cartesian coordinates. Okay. So at row 0, column 0, or 0, comma 0, or bracket 0, and then bracket 0, we have what value? 3. So, and then at row 0, column 1, we have 6, and at row 0, column 2, we have 5. And then for the next row, which would be 1, it starts over on the columns. You have 8, 9, and 6, so forth. Now, let's see how that works. Okay, yeah, so back to what I was saying about if you took the logic class, you'll remember what happens when you hit a nested loop. The outermost loop goes into suspended animation for a brief amount of time until the innermost loop completes its first run. So if I press F10 to step through, you'll now see that row is 0 and column is 0, right? This loop goes into suspended animation until this one finishes. Then and only then does the counter increment, and these get reset again. Okay, that's how you traverse it. All right, so you'll see that row stays at 0, column goes to 1, and then that's what's stored at 0, 1, and then column goes to 2, and then that's what's stored right there at 0, 2, or depending on the language. In this case, we have two sets of brackets. All right, so there's 3, 8. All right, notice what happened. It went up here and incremented row because row was still 0 while all of this was taking place. Now watch what happens to column. It gets reinitialized to 0 and the whole thing starts again. Pretty cool the way that works. See? So we go through, and I'm gonna put a breakpoint here if it'll let me, and try to run to the next breakpoint. Okay, let me do that. How about that? All right, now there's the output, see, for my two-dimensional array. And if you'll notice, if I can figure this out, there it is. So there's 3, 6, 5, 8, 9, 6, 2, 4, 9, and 1, 0, 6. All right, so there we go. So much for that. Now later on, I'm going to use the loop, some methods, functions to output this stuff, basically. All right, now here's something interesting, and I touched on this in the C# video that you just watched. Like I said, they're very similar, so I felt like I could just sort of reuse that. Here's my loop that's going to go through this string. Now, this enables you to look at every character in a string. Now, how is that possible? Well, the reason it is, if you were old enough like me to remember before we had string objects, we had to create arrays of character and treat it like a string and have a bunch of string manipulation functions in the class, because they did not exist until the string object came along. So you would dynamically allocate memory, create a single dimensional array of whatever size you needed based on programming issues, and then populate that array and treat it like a string. Okay, because we didn't have a string object. Now we do, but it still works the same behind the hood, under the hood. So what I have here is a string, remember, called my string, and I've got my space string exclamation point in there. And so what we're going to do is we're going to iterate through this thing just as if it were a single dimensional array of characters. All right, and look at that. That's the name of the string, and I'm addressing it just like an array. Index drives my loop. That's my loop control variable. Starts out at 0 and goes to 1 less than my string dot length. Dot length is a property of a string object. In C# we get into objects. You're already using objects in C++, but that's sort of above and beyond the scope of the course. And I'm indexing, I'm incrementing index by 1 every time. And these are always integers, by the way, as far as the indexes go, not what's stored there. All right, so let's see what we got here. Let me delete some of this stuff, or all of this stuff. And I'm going to add index in. And then I'm going to put my string in. And then I'm going to put my string index in. This will allow you to examine every character in the string, which is kind of cool. And this is something you might want to really learn, because when you get to chapter 13, you're doing string manipulations. When you're doing that Caesar cipher, this is one of the things you're going to have to do. Okay, so a little heads up, give you a little extra. All right, so we're going through here, and we start off index, and look at my string. See, it's got all that stuff in there. Look at these. It's treating the string as an array, because it really is. There at the first one, there's M, and guess what that 77 is? Whoops, what happened? What did I do? 77 is the decimal value associated with the M character in the ASCII chart. Another hint for that Caesar cipher. Make some notes about this. All right, so I'm just going to go ahead and I'm going to close this. I don't know how I got there. I did something stupid. I'll delete it. Delete. Ooh, there we go. All right, so F10 to step through. Why won't it let me see this? Huh, that's weird. That's not going to let me do that one. Okay. It will let me do that in C sharp, but not here apparently. All right, so anyway, you'll see what we're doing here in a minute. I'm just iterating in each one of these. Index is 0. I outputted M, and index is 1 now, so we should be outputting Y. Let's see. See? Now it's going to get the space, so it's basically just going to run all the way through this and output that whole string until it ends. Let me put run to the next breakpoint. Step down one. Okay, let's see what we have. There's my string. Okay, so I've successfully iterated through that string, treating it like a single dimensional character array, or array of characters. There it is. That's pretty cool. Okay, so now I've got my function calls down here, or method calls, depending on your vernacular language. This is the one I've set up. I'm passing a single dimensional array in, which goes in by what? By reference, by default, which is kind of opposite from what you've been using of scalar variables. It's just the way they do it. And this execution is going to jump down here to my method call. And it says here an array is passed in by reference by default. So I've got some little comments that may sort of help you out as we go through this. And I'm going to step through it. Execution jumps down to single array. And there's my, and notice I called it something completely different. I didn't have to, but I like doing that because it seems to be a little easier for students. Less confusing for me as well. Let me delete these. All right, so there's my single array. All right, so now I'm using another method. This is an intrinsic method that's available in C++ and other languages. In here, I don't know how big this is, right? But I can use the size of, and I probably could have used dot length as well, I just didn't think about it at the time, to give me the size of this array. That gives me the number of elements, right? So I've got a counter here I'm calling count. I'm setting it to the size of this array, or whatever you call it, okay? And then I'm using I less than count. I drives my loop. It is my loop control variable. So let's go through this. And there are, I think, 4 elements in there. So now it returns. See, it returned back to the calling. It's a void function, but it still has to return back to here. And it steps down, does your cout. Now let's open it up and see what it looks like. Ah, look at that. So it looped through and did that. And now we're going to call our double output function. Drop down. Whoop. Guess what? I should have stepped through. But it's the same thing as we had up above. Okay. I have X for the rows and Y for the columns, and I'm passing in these from above, so I don't have to worry about using size of. I could have done that to size those for me, and I'm just using X and Y, so it's the same idea. For every X, I've got to do so many Ys, and X goes into suspended animation until the Ys get through, or the rows and the columns. I'm putting a little indel out there, and it starts back, increments X by 1 again, and does this whole shebang. So all it did was it just encapsulated that loop we had up in main right here. So just showing you how they get passed in. That's the only reason I did that. So you can see that they're passed in by reference. And as you can see, it's exactly the same output. Let's see what we have left. I think that will wrap us up here. Let me see. Yeah, press any key to continue. All right, well, I hope this helps. I'll go over this in class as well, but I figured you'd probably needed a little something to refer back to. So enjoy.